Dimensional analysis. All that is converting from one set of units to another set of units. And it's really not that complicated, but it's easy to screw up. And NASA screwed up, right? They didn't convert to the metric system appropriately, and they messed up in their computer program, and the Mars orbiter just slammed into Mars. We want to make sure we do it right, otherwise the consequences can be significant. In order to convert from one set of units to another set of units, dimensional analysis uses conversion factors. So it's just something that you multiply by to do the conversion. So what are some examples of conversion factors? Well, they all start with a definition. For example, we know that 1 dozen equals 12. Or we know that 2 cups are in a pint. Or we know there's 10 years in a decade. Now, to get the conversion factor, we start with that definition and we divide both sides. For example, on this one, 1 dozen per 12 equals 1. If we divided both sides by 12. If we divide both sides by 1 pint, we'd have 2 cups per pint equals 1. On this one, we'd have 10 years per decade in 1 decade equals 1. So all these conversion factors, they all equal 1. All conversion factors are all equal to 1. Now, what good are they? For example, take a look at this first one. If we took some number, I don't know, 282, we can convert this into dozen. We would multiply it, right? Divide it by 12, we end up in dozen. If we had 727 pints, we'd multiply it by that conversion factor, pints would cancel, we'd end up in cups. If we have 200 decades, multiply it by this conversion factor, decades cancel, we're in years. So conversion factors, that's how they work. You start with a definition, and then you rearrange to get what you want. Now, there's some conversion factors that we just have to know. I'm not going to give them to you. And those are those metric conversion factors. So remember, they involve like milli, 1,000 milli. Let's just put everything in terms of grams. 1,000 milligrams in a gram. See, or all of these could be flipped. A gram is 1,000 milligrams. So those would be our conversion factors of converting from grams to milligrams or milligrams to grams. Another metric prefix we should know is centi, like 100 centimeters in 1 meter. And you could flip it. Deci, you should know deci. There's 10 deciliters in 1 liter. And the only other prefix that I think we really should know is that kilo. Be comfortable with it. There's in 1 kilosecond, 1,000 seconds. So all these conversion factors could be flipped and to do the appropriate conversion. So let's try using dimensional analysis to solve this problem. What conversion factors are necessary to calculate the amount of money an average OLLU student spends on drinking soda per semester? So what we're going to do is we're going to start with 1 semester. I like using these boxes because it's clear how to cancel units. We're going to convert 1 semester all the way to money. How much does a student spend on soda per semester? So what conversion factors do we need? Well, we need to know how much soda a typical person drinks per day. Now, let's just say it's, I don't know, 3 cans a day. That might be a lot, but 3 cans per day. Or in a day, there's 3 cans, either way. What other conversion factors do you think we need? Can you see? How many days in a semester? Well, I don't know how many days are in a semester. But in a semester, I know that there's 15 weeks, and then plus finals would be 16. So 16 weeks. We're going to need to know weeks to days. right? Right? There's 7 days in a week. We also need to know how much the soda costs, right, in the first place. Let's say they buy it by the case, because it's cheaper that way, right? Go to Walmart or whatever, and it's about $9 for a case. Can you see any other conversion factors we're going to need? We're going to need how many cans in a case. The case, there's 24 cans. Let's see if we have enough. Let's see if this is going to work. So let's put in everything. Now semester has to cancel, so semester has to go on the bottom. See if you can find a conversion factor with semester in it. Here it is. The semester, there's 16 weeks. Okay. Now weeks has to go in the denominator to get, so it will cancel, right? Semesters are already canceled. In a week we've got 7 days. 1 week, 7 days. Now something with days in it. Here we go. There's 3 cans per day. 1 day. Now our days have canceled. Now we got to get rid of cans. Here we go. 24 cans in 1 case. Cans are gone. Now I have to get case to disappear. In a case, here we are. We just need to flip it, right? Flip that conversion factor. In 1 case, you've got $9. So anything on top, multiply. Bottom, divide. So we'll have 1 times 16, 16 times 7 times 3, divide by 24, times 9, about $126. So that's not bad for an entire semester. So let's try a few of these. We're going to perform the below conversions, but perform them to the correct number of significant figures. Okay? So we'll see how to do that. Let's try some of these. Convert 0.0678 kilometers to meters. So always start with the measurement, 0.0678 kilometers. So this is one of those metric prefixes, you have to know it. And a kilometer, 1,000 meters. So pretty much multiply by 1,000, remove the decimal place over 3 places. 1, 2, 3, about 67.8 meters. So report your answer to the same number of significant figures as the measurement. The measurement has 3 sig figs, so we're good. Convert 18.2 milliliters to kiloliters. 18.2 milliliters. I don't know how to convert milliliters to kiloliters, but I know milliliters to liters, right? The number goes with the 1,000, with the milli, 1,000. Now the liter has to cancel, get it into kiloliters. Where does the number go? It goes with the liters. There's 1,000 liters in a kiloliter. So my milliliters canceled, my liters canceled, I'm in kiloliters. So 18.2 divide by 1,000, divide by 1,000, you get about 1.82 times 10 to the negative 5 kiloliters. Is that the right number of sig figs? Report my answer to 3 sig figs. 3 sig figs, I'm good to go. So try these and see if you get the same answer that I do. 0.00231 miles all the way to inches. So here's 5,280 feet in a mile. And then I've got in a foot, I have 12 inches. So miles canceled, feet canceled, I'm in inches. 0.00231 times 5,280 times 12. I get a big number here, 146.3616 inches. But that's way too many sig figs. I only have 3 sig figs here, so 146. Convert 8 feet per second to millimeters per second. 8.0 feet per second. And get into millimeters per second. So notice how I wrote that. I left foot clearly in the numerator and seconds clearly in the denominator. And I have to get to millimeters. I know that in a foot I have 12 inches. In an inch, there's 2.54 centimeters. I gave you that conversion up top. And then in a centimeter to meters, I know that I have 100. And in a meter, I have 1,000 millimeters. Okay, if you knew that there were 10 millimeters in a centimeter, you could have just done that too, but I don't like to memorize all that stuff. So everything on top multiply, bottom divide. 8 times 12 times 2.54, divide by 100 times 1,000, about 2438.4 millimeters per second. Now, way too many digits. I can only report my answer to 2. So I'm going to have to use scientific notation. 2.4 times 10 to the third millimeters per second. 12.8 inches per second to feet per minute. 12.8 inches per second to feet per minute. So I have to get the inches to feet, so that's not bad. 12 inches in a foot. So I'm done with the inches to feet. Now let's get those seconds to minutes. You see how to do it? Seconds has to come up here, otherwise it won't cancel. How many seconds in a minute? 60. So 12.8 divided by 12 times 60, well, 64 feet per minute. I need how many sig figs? I need 3 sig figs. I only have 2. So I can either use scientific notation or just write 64.0. That would work, right? Convert 36.8 cubic meters to cubic decimeters. Okay, let's see how to do this. 36.8 cubic meters. And realize cubic meter is just a meter times a meter times a meter. And to go from meters to decimeters, we know how to do that. Just do it 3 times. And a meter to decimeter. The number goes with the deci. Just do it 3 times. And we'll get those cubic meters. To cancel, end up in cubic decimeters. Or we could have just cubed our conversion factor. That would have been a lot less writing. So 36.8 times 10 36800 cubic decimeters. Okay. We can only have 3 sig figs. So right there, we better quit. So our scientific notation is what we're going to have to use. 3.68 times 10 to the 1, 2, 3, 4. Okay, so the name of the game here is dimensional analysis. And pretty much the plan isn't so bad. Whatever units you have here, you have to have them on the bottom, so they'll cancel. The only conversion factors that you need to know are those metric conversion factors. I'll give you the rest of them. Good luck.